Hello friends, my name is Sandip Lade. Currently I am pursuing my last year BTech in stream of Electronics and Telecommunication Engineering from Rajaram Bapu Institute of Technology. Today I am here to give the lecture on serial communication. Today I will cover some basics of communications. In deep we are going to study serial communication, its types, UART block diagram, its operation modes, two main registers, that is PCON register and SCON registers. So in parallel communication, there are the two types of communications available. First one is the serial communication, another one is the parallel communication. In parallel communication, it implies sending a whole byte of data over a multiple parallel wires, while in serial communication, it implies sending data bit by bit over a single wire. There are many popular serial communication standards exist. Some popular examples are RS-232 using UART. Next one is the serial peripheral interface, that is SPI. Another one is system management bus, and the last one is the SATA means serial ATA. So there are the two types of serial communication. First one is the asynchronous, another one is the synchronous. So in asynchronous serial communication, the transmitter and receiver do not share a clock. Here we can see that it cannot share a clock. So what is the function of transmitter here? It shifts the parallel data onto the serial line using its own clock. Also adds the start, stop and parity check bits. While in receiver, it extracts the data using its own clock and convert the serial data back to parallel from after stripping of the start, stop and parity bits.
Here is the representation of one asynchronous byte. It consists of start bit, which indicates the beginning of data word, stop bit, which indicates the end of data word. It also consists of parity bit, which is added for error detection purpose. It is optional bit, and D0 to D7 is the data bits, which is the actual data to be transmitted. Asynchronous transmission is easy to implement but less efficient, that is slower, as it requires an extra 2-3 control bits for every 8 data bits. In synchronous serial communication, the transmitter and receiver share a common clock. The transmitter typically provides the clock as a separate signal in addition to serial data. So what is the function of transmitter here? It shifts the data onto the serial line using its own clock. It provides the clock as a separate signal. No start, stop or parity bit added to the data. In receiver section, it extracts the data using clock provided by the transmitter. It also converts the serial data back to the parallel form. Now, universal asynchronous receiver transmitter block diagram, that is UART. This diagram shows the various functional blocks of UART. UART 0 and UART 1 are identical in their operation. There are two special function registers. First one is the SBUF and another one is SCON, which is used to control and manage the serial communication. Even though the programmer's model has only one serial port buffer, there are essentially two separate and distinct hardware buffers. The transmit write only buffer and receive read-only register. Writing to SBUF 0 sets the data out serially from transmit shift register through the transmitter pin. The data received on receiver pin is accumulated in the receive latch. A read to SBUF 0 fetches the data from this receive latch. The serial port control register contains status and control bits. Control bit sets the operation mode for the serial port and status bit indicates the end of the character transmission or reception. The status bits are tested in software or programmed to cause an interrupt. Next one is the operation modes. SM0 to SM1 bits in SCON register used to configure the mode of operation. There are three modes enable asynchronous communication, that is mode 1 to mode 3, while the fourth mode, that is mode 0, operate as a simple shift register. So in mode 0, it represents the 8-bit shift register. Next one is the mode 1, which represents 8-bit UART with variable baud rate, which is the most commonly used mode of operation. Next mode is mode 2, which is 9-bit UART with fixed baud rate. There is no timer required. Next one is the mode 3, which indicates 9-bit UART with variable baud rate, used if 9-bit data transmission is required. Next slide is all about SCON register. SCON register is used to select the serial port operation mode and enable or disable UART reception. The mode of operation is configured by programming the SM0 to SM1 bits. This whole table describes the SCON register. SCON register consists of 8 bits. Bit 0 represents receive interrupt flag. Bit 1 represents transmit interrupt flag. Bit 2 represents 9th receive bit. Bit 3 represents 9th transmission bit. Bit 4 represents receive enable. That is, if REN 0 is there, then it is used as a reception disable. If REN 1 is used, then it is used as a reception enable. The next one is the bit 5, which represents the multiprocessor communication enabling. There are three modes: mode 0, mode 1, mode 2 and 3. Next one is the bits 6 and 7. As I earlier explained that the mode of operation is configured by programming SM0 to SM1 bits. That is, in serial port or operation mode, 00 is used, then it is used as a mode 0. 01, it is as a mode 1. That is 8-bit UART variable baud rate. In mode 2, that is 10-bit UART fixed baud rate. Mode 3, 11, 9-bit UART variable baud rate. Next one is the PCON register, that is power control register. The baud rate doubler enables bit is PCON register. PCON register consists of the 8-bit. Bit 0 represents the idle mode select. Bit 1 represents the stop mode select. Bit 2 is the reserved mode, which is we must write 0 here. Bit 3 is UART1 enhanced status mode select. Bit 4 is UART1 baud rate doubler enable. Bit 5 is reserved bit, that is read is undefined, we must write 0 here. Next one is the bit 6, which represents UART0 enhanced status mode select. Next one is the bit 7, which represents UART0 baud rate doubler enable. If 0 is there, then UART0 baud rate divide by 2 enables. If 1 is there, then UART0 baud rate divide by 2 disable. Thank you guys for watching this video.